Hello everybody and welcome back. Today I'm going to do the final FRQ from the 1998 AP Calculus BC exam. So let's dive right in. We are told that a particle moves along the curve defined by the equation y equals x cubed minus 3x. The x coordinate of the particle, x of t, satisfies the equation dx dt equals 1 over the square root of 2t plus 1 for t is greater than or equal to 0 with the initial condition x of 0 equals negative 4. For part A, we are asked to find x of t in terms of t. To do this, we are going to have to take the integral of dx dt, and then we are going to have to use our initial condition to find c after we have integrated, and then that will be x of t. X of t equals the integral of 1 over square root of 2t plus 1 dt, where this is dx dt. And for this problem, you will need to use u substitution, which you might be able to do in your head, but for the sake of this video, I will just write it all out. So we have u equals 2t plus 1, and we have du equals 2 dt, which means that dt equals du over 2. So using this information, I can rewrite my integral as the integral, and this time I will use the negative half power to express the square root, as opposed to writing it in fraction and square root form as I did above. So this will be u to the negative 1/2 du, and then remember times 1/2 out here. And now using the power rule, we know we will have u and then to the 1/2 divided by 1/2, so that would be 2u to the 1/2. But then times 1/2 again, so over 2, and then plus c. Now I will substitute and simplify a little bit. So our u is 2t plus 1 raised to the 1/2 power, which would be the square root, and then plus c. Now let's solve for c. So we are given this initial condition at the top that x of 0 equals negative 4. So if we substitute 0 for t, we will get the square root of 1 plus 0 plus c equals negative 4. We know that the square root of 1 is 1. So if we subtract 1 from both sides, we get c equals negative 5. So I'll clear out all of this and I will just finish up our answer. So we have for our conclusion x of t equals the square root of 2t plus 1 minus 5. For part B, we are asked to find dy dt in terms of t. For this problem, we are going to take the derivative of y then with respect to t. And the function we are using for y is the one put at the top right there, where we have y equals x cubed minus 3x. Now dy dt will then equal 3x squared dx dt, this because x is a function of t. So we are going to need to apply the chain rule for this problem. Because if we are taking the derivative of x with respect to time, and x is a function of time, then we will have the derivative of the outer function with respect to the inner function, so that would be this derivative, times the derivative of the inner function with respect to t, which is this. I can now factor out dx dt, and we will have dy dt equals 3x squared minus 3 times dx dt. Now, in the previous problem, we found what x is, specifically what x of t is. So we can substitute that for x, and we can substitute the given equation for dx dt, and then we will have our final answer. So using that information, I'll move it up here, and we will have dy dt equals 3 times the square root of 2t plus 1 minus 5 squared minus 3, and then times dx dt, which is 1 divided by the square root of 2t plus 1. And this is our final answer for part B. For the final part of this problem, we are asked to find the location and speed of the particle at time t equals 4. I guess I'll start with the location of the particle. So we are going to substitute 4 into our expression for x of t that we found in part A. So if we have x of t equals square root of 2t plus 1 minus 5, and we substitute 4, and we will get the square root of 8 plus 1, which is 9, minus 5, which equals 3 minus 5, which equals negative 2. Then if we plug in negative 2 for y, we will get our y coordinate. So we will have y equals negative 2 cubed plus 6. And remember, we are adding 6 because we have a negative 2 multiplied by a negative 3. And altogether, this would be 6 and then minus 8, because negative 2 to the third power retains its negative value, and 2 to the third power is 8. And finally, 6 minus 8 is also negative 2, so the location is negative 2, comma 2. But yeah, this is the first part of part C. Moving on to the second part of part C, where we are asked to find the speed of the particle at time t equals 4. We will need to use the formula for the speed of the particle relating to parametric curves. So what this will involve is taking the square root of the derivative of x with respect to time at time t equals 4, and squaring that, plus the derivative of y with respect to time at time t equals 4, and squaring that. And this will give us our speed. So I'll just write speed at the top, and this is equal to square root, and I will plug in these values, but I'm not going to show you how to do this because I assume you are capable. So just doing this into dx dt at t equals 4, that would be 1 over the square root of 9, that's 1/3, so 1/3 squared. And then for dy dt, we can use our expression of dy dt from part B to solve this. So I believe we had 3 times, and then the square root of 2t plus 1 minus 5, and then that squared minus 3 times dx dt. And then this equals dy dt. So plugging in 4 to this expression, we will get 3. And I will plug this square root expression into my calculator, and then my answer is 3.018. And that does it for the 1998 FRQ number 6 from the AP Calculus BC exam. I hope you enjoyed this video. If you did, please give this video a like and subscribe. If you didn't, please share this video with somebody who will appreciate it. And I hope you have a wonderful day.